Hi everyone. Today we're going to study sample problems for the topic half-range sine and cosine series. Example 1. Obtain the half-range cosine series of the function f of x equals the quantity x minus 1 is squared in the interval from 0 to 1. We write our formula for the half-range cosine series here. We can see that in the interval, the L value is 1, and that is the upper limit is 1. And then we can simplify our formula into like this. Take note that the fraction here can be written as n pi x. Then we write our a sub 0 and the a sub n formulas respectively. Given the L is equal to 1, we modify again our formulas respectively. The a sub 0 is now 2 times the definite integral from 0 to 1, f of x dx. For a sub n, this is now equal to the 2 times the definite integral from 0 to 1, f of x times cosine n pi x dx. Let us now solve for a sub 0. Let us substitute the f of x value here, so it becomes like this. Let us do the integration by substitution. And the result is 2 times the cube of x minus 1 all over 3. Then we evaluate this to the limits from 0 to 1. So we have this 2/3 times the quantity 1 minus 1 with exponent 3 minus 0 minus 1, and this is with power 3. This 1 minus 1 here becomes 0, so we can cancel this out. For 0 minus 1, it becomes negative 1, and when we put power 3, we have this negative 1. So we copy the 2 over 3 down here, minus the negative 1. Negative times negative is positive, so final answer is 2/3. This is the value of our a sub 0. We copy this opposite the a sub 0 formula here. Then we proceed to a sub n. Let us substitute the f of x value in here. Then let us solve for the integral. Remember that we are using the Bernoulli's formula. So the u and the dv are here. For the u, we will differentiate till it reaches 0. So we have this u prime equals 2 times the quantity x minus 1, then times 1. We don't write it anymore. U double prime equals 2, u triple prime equals 0. For the dv, we will integrate. Integral of dv is v, and integral of cosine n pi x dx is 1 over n pi times sine n pi x. Integral of v is v sub 1 equals negative 1 over n square pi square times this cosine n pi x. Integral of v sub 1 is v sub 2 equals negative 1 over n cube pi cube times sine n pi x. Then we substitute the corresponding values to our a sub n. So we have this 2 times, we have this first pair of factors, this is our u times v, minus this second pair of factors is u prime times v sub 1, plus this third pair of factors is u double prime times v sub 2. Then we evaluate this with respect to the limits from 0 to 1. We have now these two big groups. We're going to simplify with respect to our standard result, that is the sine nx equals 0. Please observe our first group here. This factor here as 1 minus 1 becomes 0, and this is squared, and the whole pair of factors becomes 0. Also, this 1 minus 1 here is 0. So, this whole pair of factors will be 0. And in the third group, we have the sine n pi that will make this 0, which means the whole first group is cancelled out. For the second group, we have the sine n pi here that will make this as 0, and we have this sine n pi here that will make also as 0. Then we will simplify this group in here. The cosine n pi 0 means cosine 0, and this is simply 1. By simplifying this, we will copy this negative 2 here. The 0 minus 1 is negative 1 times 2. We write negative 2 here. Then we copy the denominator, n square pi square. We multiply this negative 2 by negative 2. We have the positive 4 over n square pi square. This is the value of our a sub n. We copy it here. Now we substitute the values in the half-range cosine series formula. So the a sub 0 becomes 2/3, and the a sub n is now this value. We simplify this complex fraction as 1 over 3, and this is now the final answer. Example 2. Obtain the half-range sine series of the function f of x equals Lx minus x squared in the interval from 0 to L. We write the half-range sine series formula, and it is in here. Then we will solve for the b sub n. The b sub n is equal to 2 over L times the definite integral from 0 to L of f of x times sine n pi x over L, then dx. We now substitute the value of f of x in here. Then using the Bernoulli's formula, we will now identify the u and the dv. U is equal to Lx minus x squared, and the dv equals sine n pi x over L, then dx. For the function u, we differentiate till it reaches 0. So we have u prime equals L minus 2x. U double prime equals negative 2. U triple prime equals 0. Then we stop. For the dv, we will integrate. Integral of dv is equal to v equals integral of sine n pi x over L dx is now negative L over n pi times cosine n pi x over L. Then the integral of v is the v sub 1 equals negative L square over n square pi square times the sine n pi x over L. The integral of v sub 1 is the v sub 2 equals L cube over n cube times pi cube times the cosine n pi x over L. Then we substitute the corresponding values to our b sub n. So it becomes like this. This is equal to 2 over L times, we have here the pair of factors. This is our u times v, minus the second pair of factors. This is u prime times v sub 1, plus another pair of factors. This is u double prime times v sub 2. Then we evaluate this with respect to the limits from 0 to L. We have now these two big groups. Let us analyze one by one. Let's begin with the first big group. Here we have L times L, that is L square minus L square. This becomes 0, which means this pair of factors becomes 0 later. In the second pair of factors, we have this sine and pi. We know that this will become 0 later, so this will be cancelled out. For the third pair, we have this cosine and pi. This L and L we can cancel, which means later we will substitute the value of -1 that is raised to n on this group. Let's go now to the second big group. In the first group here, we have the cosine n pi times 0 over L, which means this is cosine 0. This becomes 1 later, so we can simplify the first group. In the second group here, we have this sine n pi times 0, which means all of this will be 0 later. In the third group, we have this cosine n pi times 0 over L, which means we have the cosine 0 here, then it becomes 1 later. We collect now the remaining terms. We have this in the first group 2 over L times the -2 times L cubed. Then we have this quantity -1 that is raised to n all over n cubed times pi cubed. Minus, we collect the remains in the second group. This is 2 over L times, in the first group here, we have L squared times L over n pi. Minus, this one becomes 2 times the quantity L cubed over n cubed pi cubed. In the first group here, we can cancel this L in the denominator, and we have L cubed here in the numerator. In this second group, we're going to distribute this -2 over L to each of the terms of the group. And then we will simplify by cancelling this L in the denominator to the L in the numerator respectively. So we have now these three fractions. Look at the first fraction and the third fraction. There is common in them. We can rewrite this into 4L squared over n cubed pi cubed times the quantity 1 minus the -1 is raised to power n. Minus, we just copy the second fraction down here. When we analyze this, we can see that there are two values of b sub n. So b sub n equals 8L squared over n cubed pi cubed minus 2L squared over n pi. This is when n is odd. Also, b sub n equals the -2L squared over n pi when n is even. Let us copy the values down here. Now let us substitute the b sub n values in the half-range sine series formula. So we have now f of x equals, this is the value of b sub n when n is odd. To satisfy this, we write in the lower limit n equals 1, 3, 5, and so on. Then plus, this is the value of b sub n when n is even. To satisfy this, we write here in the lower limit n equals 2, 4, 6, and so on. This is now the final answer.